Ini kalau saya bicara langsung masuk ya berarti? Enggak ya? Oh. Apa? Iya, ngirim background di grup. Iya, iya, iya.
This is the time to let our light shine.
Iya ya, maaf banget.
This is the time
Ini Pak Pak Dekannya mohon waktu 5 menit. Ini pesertanya juga masih segini. Aduh. Jangan-jangan nih gak ada mahasiswa yang dateng nih. Kalau nggak diwajibkan ya. Ya kan? Aduh.
This is the time to let our light shine. And you know it's true. This is the time.
Recording in progress. Mulai Bu ya.
Ya, baik.
Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. May peace be upon us all. Welcome to the guest lecture organized by Department of Civil Engineering, University of Jember. It is truly an honor for me to serve as your Master of Ceremonies today. Before we begin, let us express our gratitude to Allah Subhanahu wa Ta'ala for His blessings that allow us to gather here in good health to participate in today's academic event. To begin our event, please join us singing the Indonesian National Anthem, Indonesia Raya.
Am I audible?
Thank you, ladies and gentlemen. To officially open our event, let us hear the welcoming remarks from the Dean of the Engineering Faculty, University of Jember. Please welcome Dr. Insinyur Triwahyu Hardianto, STMT. Bapak Triwahyu, the time is yours.
Okay. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Warm greetings to all of us. The Honorable Professor Asya Akhtar, MX FHD. Welcome to Faculty of Engineering, Prof. Asya Akhtar, and our distinguished Head of Department of Civil Engineering, and also Secretary of Department of Civil Engineering, and also Coordinator of Study Program of Civil Engineering, distinguished guests, college participants, and all of attendees, and also all of committee, and special our distinguished our students, Civil of Engineering. First of all, let us express our gratitude to God Almighty because with His blessing and grace we are able to gather here today at the guest lecture with topic is urban water resilience through rainwater harvesting, lessons from research and practice, hosted by the Department of Civil Engineering, Faculty of Engineering, Universitas Jember. We are deeply honored to have Prof. Asha Akhtar with us today. Her outstanding research and practical contributions to the field of urban water resilience and rainwater harvesting have inspired many around the world. The topic of today's lecture, Urban Water Resilience through Rainwater Harvesting, Lesson from Research and Practice, is highly relevant to the global challenge we face today, from climate change and water scarcity to the rapid urbanization that puts increasing pressure on our water system. Through this session, we hope to gain valuable insights into innovative approach for building resilient and sustainable urban water systems. I also believe that this event will strengthen academic collaboration between the University of Jember and Chittagong University of Engineering and Technology in the future. Once again, I sincerely thanks Professor Asha Akhtar for sharing knowledge and expertise with us. May today's discussion inspire us all to contribute to a more sustainable and water secure future. Please ask for permission to open guest lecture by saying Bismillahirrahmanirrahim. This lecture officially started. Thank you very much and enjoy the lecture. So I received to Master of Ceremony. Thank you very much.
Thank you very much, Bapak Triwahyu, for the warm and inspiring remarks. So, ladies and gentlemen, now we are moving to the main agenda of today's event, the guest lecture session. For this session, we will be guided by our moderator, Ms. Retno Utami from Department of Civil Engineering. Therefore, I would now like to hand over the session to our moderator. Please welcome Bu Retno Utami. The time is yours.
Thank you, Bu Selmi. Good morning, ladies and gentlemen. Honorable Speaker, Prof. Aisyah Asar from Chittagong University of Engineering and Technology, Chittagong, Bangladesh. Honorable Dean of the Faculty of Engineering, Universitas Jember, Dr. Insinyur Triwahyu Hardianto, STMT, POCNN. Honorable all study program coordinator, all lecturers, and all students of Faculty Engineering, Universitas Jember. Assalamualaikum warahmatullahi wabarakatuh. All praise is due to Allah the Almighty. By His grace, we are able to gather here today on this very nice occasion. And it's such an honor for me, Retno Utami Agung Yono, to serve as moderator in this international guest lecture. Before coming to the main session, I firstly introduce our speaker, Prof. Aisyah Akhtar from Chittagong University of Engineering and Technology, Chittagong, Bangladesh. She is a distinguished academic and researcher in civil and water resources engineering with over 2 decades of teaching, research, and leadership experience. She has made significant contributions to the fields of hydrology, river engineering, flood management, and sustainable infrastructure development in Bangladesh. She completed her Master Engineering in Water Engineering and Management from the Asian Institute of Technology AIT Thailand in 2005 and later earned her PhD in Civil Engineering from Heriot-Watt University in the United Kingdom. These academic milestones equipped her with strong technical expertise and an international outlook that she has since applied to research and teaching. Today, the title of her presentation is Urban Water Resilience Through Rainwater Harvesting, Lessons from Research and Practice. Now, let's hear her presentation. Prof. Aisyah Akhtar, the time is yours.
Thank you. Let me share my slide first.
Please.
Is it visible now?
Yes.
Okay. Thank you so much, honorable faculty members, as well as the participants and students. Okay, let's start with a very good morning. Here in Bangladesh, it is 7:21. Uh, good morning, everybody. Welcome to my presentation on urban water resilience through rainwater harvesting, lessons from research and practices. And in the left corner, you will see one book which is titled Rainwater Harvesting, Building a Water Smart City. This is written by myself and published back in 2022. I'm Professor Dr. Aisha Akhtar, as already mentioned about my educational background, and I have been working since 2005 in the Department of Civil Engineering, University of Engineering and Technology. This is the typical experiences when one people need some water and there is heavy rain outside. This is just an arrangement to catch rainwater, which will be used afterward. And one history I found that because I have studied my master's from Thailand, they have back in 80s, they promoted a kind of bucket which can contain rainwater, and afterward this can be used for potable and non-potable use. And this beautiful architectural shape is from USA, which is also a very good example for rainwater harvesting, and this is used for, and this is both together. One is a very good architectural view, as well as this rainwater can be used for both potable and non-potable purpose. What interested me back in 2013, which is almost 12 years ago, uh, a severe waterlogging we experienced in my city, Chattogram, and these are the photos of waterlogging. Whenever heavy rainfall happens, this got waterlogged for a few hours and causing a severe disruption of the urban life. And it's not like uncommon in other cities. And I have started work with my research group since then. And then I try to find out, as there is a storm water, that means the heavy rainfall happens, why and which month should be carefully we consider for the further analysis. And with that time, there are 5 years rainfall data that showed me the heavy rainfall time should be from the late May, and right now it is October. And this, according to this graph, this October, mid of October, this year we don't have much rain last week, but that time the water years which got heavy rainfalls, it continues sometimes starting of October. So this is one issue. If we can have rainwater harvesting, and then this rainwater can be slow down the generated runoff. And afterward, one research we could make for a small part of the city, which contains different kind of rooftop. but we preferred the rooftop which is concreted, and those rooftop we selected for the rooftop rainwater harvesting and one potential rainwater harvesting for urban area we could proposed, and this is quite a good number of success story, because after this work, this city developed the master plan and included in water harvesting in their plans. And also, this research article has published in the Journal of Hydrology, and afterward, this was awarded from the Bangladesh University Grants Commission as a best research in 2015. The journey of urban rainwater harvesting, I am already sharing with a few of the experiences which personally I had. And also, meanwhile, I will also discuss what can be the supplementary water sources, how can be the urban floods reduction we can make through rainwater harvesting, and also the groundwater recharge that the next step we wanted to accommodate. And challenges, yes. When I compile my rainwater harvesting book, and that time I tried to grab all the information which is available and the published information around the world. And what I included, that is the experiences which my city, Chattogram, experiences. One is heavy rainfall, another one is the tidal influence, because we are very close to estuary, and one of the main river, which obviously that is the tidal river. Some spots already having like inundated, not necessarily having heavy rainfall or not, but this is usual. We have some places which got inundated for like 20 to 27 minutes, but we have inundation which caused waterlogged few places. So how rainwater harvesting journey can be for supplementing water source, reduction urban floods, and also groundwater recharge. And then I would try to make some concluding remarks on water smart cities. Well, this long queue is for collecting drinking water, and at the bottom, as there is no water in our in the pipeline. So the next step is people it is conventionally they just collect the rainfall. This is I when I written my book, this is quite 1,000 years history. People just collect the rain and use as a fresh water. Well, the history of rainwater harvesting is since the Bronze Age, and this is for the supplementing water supply. Uh, Through the Neolithic age, this rainwater is stored for not only drinking purpose. Sometimes it also is stored or harvested for making a place cool. That means the places where it is it used as a air cooler. So the concept of rainwater harvesting started with supplementing water supply. Then some places it also used a different purpose, as I mentioned, from historical Latecourse, it can be found that it is used as also uh, cooling purpose. It's also used for gardening purpose, other non-potable application. So what happens when urban hydrology we consider? This is the typical hydrological cycle, and this is the urban hydrological cycle, and we can figure out the changes. So when we introduce some buildings and urbanization progresses, and then the first thing we just cut down the infiltration, what we can get from the hydrological cycle naturally. So the first thing we interrupt the infiltration, and the next thing we generate a huge runoff. So these two changes progresses as urbanization progresses. So all these figures I have shown over there, this is from my book. So what we know from our sustainable definition. For sustainable definition, it comes all together from environment, economy, and society. And uh, at the bottom, I just picked the issue, the quality and water pollution, because water supply be uh, should be same as water demand comes from the community. This is a sustainability concept we understand, and it's a picture of a balance. And at the bottom, these issues, timing, abundance of fresh water, and this fresh water should be the standard quality and should not be water uh, pollution. Well, the rainwater harvesting system, this is the typical rainwater harvesting system having 7 components. Mostly people wanted to see 3 components. One is roof catchment, then the pipe networking, and then the storage. So meanwhile, the roof catchment, you cannot impose a city having same shape of roof. So we found that there could be like 10 to 12 types of roof catchment. One thing I have proposed in different places, and I found that significant people agree with me that this roof catchment, how we can calculate. And this catchment area can be calculated. What I suggested that this calculation can be done as rooftop footprint. So this footprint would be a simple projection of the whatever the shape of the roof is available, this roof. And then this storage, and that is another big issue because if we look into the urban areas, a single story building have the catchment area which is similar to a building having 12 story, same catchment area. If we just consider the rooftop, so there is a scarcity of the catchment, and the catchment, if we can plan in such a way with the help of architect, that the vertical walls and any other open places we can consider as a catchment. Well, we collect all the water and wanted to store. And this storage is another issue which impose cost. Because if we just consider 120-story building having all the rainwater which we have collected and stored in underground storage, that will impose further costing for pumping to other floors. So what I found that could be a consideration, rooftop rainwater harvesting should be for the multi-storied building, should be for few floors. And then in the second figure, you may find that the intermediate level rainwater storage can be. And the last one is the underground storage can be. This is a very beautiful photo of a household plumbing system which considered rainwater harvesting along with the main water supply. So this supply system started with number 1 and it ended at number 18, the dishwasher. This also included a hot water line, which yellow color, and another one is we wanted to use this like harvested water. So harvested water is collected from different places. I will come later also, because now I am talking all about the rainwater harvesting, but we have idea to other combined with other source of waters to make it sustainable. So this is the typical urban plumbing system can consider using rooftop or rainwater harvesting. Rainwater treatment, that's the another issue. The rainwater treatment, if it is collected from rooftop, rooftop, veranda, porch, open space, and also the vertical walls, there are possibly a very limited contaminant in the rainwater. So there is few treatment is okay for using non-potable use, like this picture. The first one is showing we can use as a flushing purpose. We can use for mopping purpose or the cleaning purpose. So this kind of use doesn't need high quality water, but a few treatment is sufficient. Well, now I would move to stormwater management, and this figure is also from my book, and it's a great message conveyed that whenever we have uh, this waterlogging problem, as I showed you, the inundated street, inundated road. So if there is any place we can point it out for a bioretention soil. So far, I understand well, today we have different participants who different grade participants. Um, I will try to make it easier. Like, what is bioretention soil? The bioretention soil will, like a simple word, it would collect the runoff uh, on a spot, and there would be like some grasses or vegetation which would be a very potential intake from the collected water, and they will have a minimum amount of discharge, so that whenever storm water causes urban runoff that may reduced in the downstream, because if you find that most of the places is vulnerable, that is the downstream. Okay, so this is the concept, and when I go further then I found some challenges, because when we consider the stormwater runoff in the urban environment, it contains contaminant. It contains pesticides, organic material, metals, nitrogen, and phosphate. So, considering this, we need to pick one solution. Is it is bioretention soil, or if it is rain garden? In this point, I would say few examples, like rain garden, bioretention soil. I have also included this type of solutions, which is already practiced in different parts of the world. These are used as storm water reducer or management purpose, and they are also known as low impact development. So this low impact development, if you see how it works, the first thing is the surface layer, then the pavement layer, and then the storage layer. What does it mean? That means whatever runoff we have, they will be filtered through these media, and then and this is gradually developed in different parts of the world. And another similar concept is green stormwater infrastructure. So green stormwater infrastructure having component the surface water, groundwater, as well as underground infrastructure, how it works. So the green stormwater infrastructure also another concept to reduce stormwater runoff. This is I really like that this concept, which is sustainable drainage system design. It consider water quantity, water quality, biodiversity, amenity. Without biodiversity, we cannot design a total system. So we need to consider both of these, all of this, and the stormwater management, as I mentioned, like there can be a rain garden. So starting from left, this is the green roof system. So if we can identify what is our purpose, if it is only stormwater management, then we will not accommodate our roof as a rainwater harvesting catchment. We will move for a green roof system, and over there will be at least 5 layers. An intermittent layer, we will use filter media like geotextile. Then the right hand upper figure, it is showing the rain garden. Typically, it happens whenever you have a garden and the watering comes in the wet season from rain. Not much effort we need for this rain garden. And all together in one urban area, it can be at the bottom there is a arrangement. At the left, you will see a high-rise building, which is 6-storied building. I like this 6-storied building because in Bangladesh standard, building like more from 6-storied onward considered as a high-rise building. So I have started with 6-storied building. so that my understanding makes clear to the reader, and that in urban area having 6-story building or more can use rainwater for rain garden, for non-potable use. At the left, I have that arrangement. In the same city, there can be also bioretention soil, and also um, uh, some people don't bother to have high-rise building. They can afford a beautiful two-story building, can consider a green roof for their accommodation. There is the bioretention basin plan, which is one challenge, I would say. Um, if it is the urban area progressed already, you cannot accommodate a bioretention basin nearby. You need to find out a place which have considerable area can accommodate the bioretention basin. This can be also incorporated in car park, and I am more interested to incorporate in car park in islands this bioretention basin. And my research team is working how can we accommodate in these places, because car park is a very potential zone. And local cityscapes also I have described uh, to make it like having plenty of spaces and planning for future urbanization, that places can be considered for a biodetention basin. From this chart, well, I am sorry, I don't have much information regarding Indonesia. What I wanted to learn about, like from today's audience, uh, in this figure, I just make a click and just pointed out when Bangladesh has started thinking about stormwater management, because we have a we our country is riverine country, having river induced flood every year, and having urban flooding is not unusual. We experience in monsoon some places twice or more. So flood action plan, which was the milestone back in 1987. Then 2013, National Water Act has uh, uh, started thinking about different phenomena, but particularly stormwater management. And right now we have 50 years master plan on water sector, and this not only water sector, and it's called BDP, Bangladesh Delta Plan 2100. Okay, so for water smart cities, we produce plenty of grey water from kitchen sink, from water purifier, from bathroom, from washing machine. And we never bother about this water. But if we can collect them and have some minimum treatment, we can store, and we can use as a flushing purpose, floor washing purpose, car washing, and gardening purpose. See, same type of concept I have already shared with you regarding rainwater harvesting. So grey water use can do all these things. So grey water have like ecological advantages, which included uh, one thing I would say soil fertility, which can increase, which can reduce is the landfill. So this can also increase plant growth whenever we use for gardening purpose. And we can this all together can conserve water use. Okay, the management advantage is extending life of septic leach field, can reduce pumping cost, can conserve water, and it can lower the water bill, and also the climate safety issue. So grey water use, this picture is showing grey water, and this picture also integrated grey water and in water system with indirect non-potable supply. So this is not uh, consumable. This should be used for all the non-potable use. And whenever we are done with our household system, we can just at the point 15, you may find, we can just drain from the system whatever the excess water we get. The managed aquifer recharge, because I don't want to make you bore why I have suddenly entered in the managed aquifer recharge. Because in the urbanized area, we will face minimum or reduction in natural recharge. So we need to consider if natural recharge hampered, we will face the difficulties groundwater lowering. So whenever groundwater lowering happens, then we need to find out alternative solution. Already that alternative solution, managed aquifer recharge, uh, entered its fourth stage. So it has already a glorious history, managed aquifer recharge, uh, and it has already entered in its fourth stage since 1990. So how could be the aquifer recharge practices? So these are the figures. I have some example in my book, one six-storied building and one luxurious two-storied building. So showing a recharge speed, a recharge oil, typical dry oil, and dark oil. In many places, I would say, especially in India, they have already adopted a very beautiful concept about this managed aquifer recharge, and some of the figures I have get concept from their guidelines, and I have prepared for my book. And this one is the aquifer storage, transport, and recovery in confined aquifer. And this shows like 1 to 7 how we can get groundwater treated through managed aquifer recharge. Managed aquifer recharge have very good number of advantages, which could reduce inundation, because I don't want to leave that scenario in any urban area, urban stormwater runoff, which is very common, and any urban area experiences this waterlogging, or sometimes it is also called as nuisance flood. Managed aquifer recharge can provide space for subsurface storage, which has negligible evaporation loss, and then enhanced infiltration, because the layer which we would select for designing the managed aquifer recharge, uh, possibly the permeable media. And this can also have socially acceptable. The managed aquifer recharge, which we are talking about, is managed aquifer recharge will be done using the fresh water so that it can be conserve the soil. Also, it can provision of a underground water storage, which is relatively safe against any disaster, because we wanted to uh, supply, not only supply water but also conserve our nature, having the managed aquifer recharge. Few challenges are there. The system is expensive. Uh, and once we are uh, consider about the cost, then probably we may think about grey water reuses cost be health issues. Grey water reuse can be also some country needs clearance from regional health department. Also, the grey water system, which we said using or reusing, its reliability. Sometimes people are not motivated enough. Don't want it to reuse grey water. So water quality, regulation of reused water quality. I need to check again. Is there any global standard is available? Because I found some of the countries, they are having the nationwide initiatives. So heavy rainfall. Well, I would back to my story. Heavy rainfall was there. I have started with 2013's heavy rainfall. Then 2017 is there, and it also triggered the what it called the uh, inconvenience has triggered when there is a cyclone, because the city I am living in also having tidal effect, cyclone effect, and every year a storm runoff there. So water logging has the issue, and we found that there is a very minimum data set back in 2012. So we have started like from the SCAP, getting data door-to-door survey, and the beautiful ending of this story is we could point it out which are the area can be waterlogged area or can be hotspot of water logging. So this is help our master plan, and still you might wondering that there is no waterlogging. Yes, it is still existed, but few improvement we got. That is after a heavy rainfall, we need to wait like 1 hour 15 to 1 hour 30 minutes. Those water is slowly moved from the places. So this is quite good in this city, which is belongs to a developing country. There is often a fund crisis exists. So what is another potential issue? Another potential issue is um, the land use changes. And sometimes my students take me huge debate. We shouldn't say it is waterlogging. It has sometimes flowing water. We try to make a model using PC Swim, which needs license. But it can be also done using Swim model, and we evaluated this runoff in terms of land use changes. For these findings, we come up with the idea, a hazard map for 5 years, and this is still this has already finished its work back in 2018, but we are still working to see how it progresses, because as we take consideration about this urbanization rate is around 2.3% in Chattogram, which should be considered for future flood hazard modeling and runoff quality assessment. Another issue is proper drainage system. I'm sorry, this figure is not so nice to present. However, this is the scenario is cross-sectional checking. Some places has already built the a drain, and it has losing its convenience or the capacity of carrying, because insufficient depth. So we just went there to uh, get the information how much depth it is having now, as well as width, because it can be the workmanship, as we have the record. It's supposed to be 80 centimeter, possibly over there it's not 80 centimeter, it can be variable. So we checked all through the drains, and this map which I am showing at the left hand side, this is the whole city area, Chattogram city area. So this work has done also PCSOM model, and we tried to find out the hot spots, and this got a very useful publication in ICE water management. And our city mayor liked this work very much, and in an international conference, it was declared the best paper, which considered all this information and which really helped the next master plan. Next master plan decision making, because presently our city is working on developing the master plan, and along with this they are continuing their work. As I said, a small part we have started with the rainwater harvesting potentiality, and this time, this potentiality we considered both way, not only the potable purpose. This consideration extend until the stormwater management, and the whole city having 12,000 roof, and all are not concrete roof. Some of them are thin. I am not sure whether you used this corrugated iron material for roof purpose. So this is the rainwater harvesting potential index for building rooftop, and we tried to see, okay, the idea which is taking some portion of vertical wall as a catchment. This 3D view would help us where the building is like 5 storied or 20 storied, and after that we a researcher from Bangladesh. I have also get opportunity to participate there. We suggested that 50% of vertical wall can be used as catchment. Okay, now the point is why 50%? Why not 70% or like 100%? Because for the safety concern, for not all the owner is aware about the facing of their accommodation. So this is roughly 50% we could include in Bangladesh Building National Code, which shortly we used to call BNBC. But we also found that it can be even increased, because if we just go with this rooftop, that might not like might have the same roof as a lower story building. Okay, prospects of rainwater harvesting. We motivated with a simple math back in 2013 per meter square catchment area. Each year can accommodate 1.5 to 4.5 meter cube of rainfall. So we may reduce this stormwater runoff inundation, and we can supplement this no water scenario. So considering all these prospects, what we today explain, supplementing improved water supply and self-sufficiency to water supply in terms of quality. Oh, okay. If it is only rainwater harvesting, it can offer high quality water, which is soft and low in minerals. It can improve groundwater quality through dilution during the groundwater recharge, and it can reduce soil erosion in the urban areas. Management and economics, which is cost-effective system, simple to construct, operate, and maintain. Also, it can lower the pumping cost. Many courts around the world has considered rainwater harvesting. Some interesting finding I found that some of the code even consider exemption of income tax of for rainwater harvesting, which really interested me. And this invention started from Washington, and presently another practice is found in California since 2013. They couple groundwater, gray water, and rainwater. And for me, I have opportunity to visit California, and that is the university campus. I stayed there, and I found they have like that system is not in Bangladesh, but they have some even waste collection, waste decomposition on a spot in their basins. I am not sure whether in your place in Jember has the same thing. Like in kitchen waste, need not to dump in other polythene. It can be dumped all in the dishwashing basin, and it make small particles to decompose. So they have the grey water and rainwater alternative sources together. Bangladesh rather new to consider rainwater harvesting, especially for groundwater recharge. Some of the standard, I would say, groundwater replenishment in also. I found our neighbor country, they have started back in 2008. Australia is also one of the prime country who has designed rain tank back in 2006. So people has started work with rainwater harvesting in different areas and placing different marks. This is the rainwater not suitable for drinking. Pick attention. This is not non-potable water. Sometimes the toilet are flushed with recycled rainwater and make a notice do not drink. Uh, and some places also give awareness about the clear water. And also we consider and we will move to water smart cities. Our urban will be sustainable concept because in places the term is different, but our aim is same. We want our urban to be sustainable for our next generation. So the benefit for adopting a water smart city, which can integrate water cycle management approaches, minimizing potable water consumption, protection of water quality in waterways, and reduction in runoff, so that on-site stormwater detection can be ensured. Blue and green infrastructure in the streetscapes can have a cooling effect and buffer the urban heat island effect. In my presentation, two things I found it is lacking. One is starting with the urban heat island effect, because these are the fields for me. I am still learning how this can be incorporated. Another one is the cooling effect. Yes, yeah, I have recently visited also Thailand. Well, I am also in Bali, in Indonesia. So all this country, we also need some cooling effect during summer, and you also might having the same experience. There is rainfall outside, but not enough cool. It's still suffocating. So if we can work on this, that will be really nice. So for water smart cities or the sustainable urban areas, we need to work together with a planner, with a architect, and also the civil engineer. We need to build up a kind of water resources modeling, and this engineering can be helpful for all this purpose. We so far I mentioned, maybe beyond this, some other points can be included for the water smart cities. So within a city, innovation could lessen the demand, escape stick watering schedule, ensure nutrient-rich rainwater to the landscape, then manually or the major water supply system or the municipal water supply system, reduce chemical exposure, and reduces fertilizer uses for gardening. So altogether, what we can understand, urbanization will be there. Because by 2050, urbanization in some places will be double. So for the urban life, we don't want any more no watering tap. We also don't want urban flooding. We just wanted to collect the water and uh, well, we would heading towards a sustainable urban area, which might called water smart city. Thank you.
Thank you very much, Prof. Isaac, sir, for the very inspiring and full with the knowledge session. So now we go to the discussion session. Please, all students or lecturers or college who want to ask question to Prof. Isaac, sir, you can raise your hand or put the question in the chat room. And Prof. Amtin Hide is also here. Thank you, Prof. Okay, I saw one raised hand. Okay, first I actually have question to Prof. Isaac, and maybe just small answer to your question about rainwater harvesting. And I also would like to congratulate to your book, Rainwater Harvesting in the Springer, if I'm not mistaken. About the rainwater harvesting itself, in Indonesia, actually, we have a regulation in 2009, actually, and it is specifically about rainwater harvesting that is released by mm, environmental ministry. But the challenge or the limitations that we have in Indonesia is that the regulation is there, but the implementation is very low, if I can say. Even in the capital city of Indonesia, in Jakarta or Bali, but and also in Jember, as you can say that the cost to make and to implement the rainwater harvesting is not cheap. So it is a very big challenge for us. And one question from me about that is how Bangladesh government or the ministry or maybe you have community or something, how you can enforce or give any motivation to the people to make rainwater harvesting implemented in your country or in your city.
Well, this is a really very good question. Thank you. This is really very good question. Okay, when I say my city is Chattogram, that is semi-true because in Bangladesh, the coastal city where I am working, this is in southeast, and my city is from southwest, which is belongs to renowned coastal area, and that is the mangrove area, having saline water, pure saline water. Another introduction I can say about my hometown, the place where I born, and that is the saline water is so much, and this like uh, mm, 30, 40 years ago, they don't have drinking water a very good source, so that they just declare one pond as a drinking water purpose. Okay, so what the people from my grandfather times, so far I am the eyewitness, they used to collect rainwater, and that place now in 2025, that place and nearby other places are still not developed much, but they have a provision. I am trying to convert the amount, but well, for Bangladeshi taka, it is around 12,000 to install one rainwater harvesting. So when from government, it was not government initiative, it was like non-government initiative to provide them one uh, place which is like only a place having concreting and some finishing to make it catchment and collect all the rainwater. And this rainwater harvesting system, they supply water, they collect water for drinking purpose 6 to 8 months. So after rainy season which extend like uh, heavy rainfall starts mid of June, sometimes starting of June to end of August or mid of September. So after this 120 days, we just calculate like 120 days is the collection time for us, and the rest of the water time we will offer for using the from storage. So it is working there. Okay, so my city in Chattogram, some places people individually collect water. That's also applying, and some of the what it called some of the service provider, better it is called the implementer of high-rise building, they have adopted. We have a standard, but we don't have laws. We have laws, but we don't have that system. If you don't have rainwater harvesting, there is no uh, monitoring system. It's kind of optional. You have implemented or not, but law enforcement is not there. But in building code, we have, if the roof area is more than 300 square meter, you should implement one rainwater harvesting, rooftop rainwater harvesting. But this is a small invention. We need to move for like more general and awareness should be there. But the practicing, the places which got already practiced, we need not to make much effort for them. This is the issue. And we don't have like any tax exemption system, which has already Washington has. And another thing is for the low income group, this is their only option to get fresh water. Otherwise, what they do, they need to purchase this rainwater with higher cost. So this is really a big concern for them also, because the water which I purchase per liter, it is almost 10 to 15 times more for them when they purchase. So they prefer to go for rainwater harvesting, especially the places which got salinity, huge salinity problem. Sometimes arsenic also.
Thank you very much, Prof. Isaac, for the answer to my question. Okay, now I will invite another college and also student who uh, want to ask Prof. Isaac about rainwater harvesting. Maybe it's another topic, but maybe the yeah, just young lecturer here would maybe rather shy to ask about an opportunity to go to the doctoral course in your university.
Okay, that is really good. I am trying to figure out the places where rainwater harvesting system was offered after having a good donor. And once the project has finished, as you mentioned, similar experiences we also have. When the project finishes, people are not interested because the conservation is something different rather than the necessity. If you have just the only one option, have the fresh water, and this is without cost or minimum cost. But if you have the option, okay, you can do or you can ignore, that won't make much sense, much difference, then possibly it's really difficult. But yes, I am trying to do a story, not only the successful story. I also wanted to conduct a story how many rainwater harvesting systems failed from Bangladesh. And also, last week I have been in AIT, giving the similar the presentation to get some ideas. And over there, I also heard a story from Philippines. So yes, the scenario is relatively similar because yeah, whenever people have option, then there could be option to not to choose as well. So we can have a collaborative research work first, and then we can move for the implementation. We can work on this issue.
Thank you. Thank you very much, Prof. Isaac. Sorry, Prof. Antin Hidayah. I think you can um, put your question now.
Thank you. Thank you, Prof. Aisa, for sharing in my campus. I have some question. The first is, based on your experience, how would you describe the success of green roof implementation in reduction flood impact or managing water in your area? Maybe the second is regarding the implementation of low impact development measures for water recharge. What the challenge or obstacle have you encountered? Because in my country is in Jember still rare for like this year. Thank you,
Okay,
Aisa. You can,
thank you, Professor Entin. Recently, last month, one of our research paper on green roof has published from Cleaner Water. The thing is, the green roof concept I did so many model study, uh, so many study area we are trying to work on. And in parallel, in Bangladesh, in urban area, there is a trend having gardening, roof gardening, but there is no formal green roof concept. Green roof concept, which I have seen in Australia. A reduction from the model study, we found that the reduction can be more like 26% if this rainwater harvesting we do. That is we found from our study, but there is no formal green roof. But you will be happy to learn one of my research project currently going on. We wanted to build in with real-time controller RTC rainwater harvesting. So this would make a pilot project in Department of Civil Engineering in Chuet. So we are working on this. Probably this would be the first work and monitor how much reduction we can do. So we have started that project, and this year we spent time to make the literature and the possibilities, the networking. So our target is from next season, next rainfall season, started from mid of May. So then I can say how much I get the runoff reduction, as well as my notion is not only the runoff reduction. If we can generate an idea and we can make a pilot project, if it is heavy runoff, how the RTC or the real-time controller system works, it can be used anywhere around the world, not in Bangladesh. Thank you.
Prof. Antin. Prof. Antin.
Thank
Ay.
you. Trouble. Unmute. Thank you, Aisa, for your answer. It's good. Explain. The second, uh, I want to know about the mapping model, flat mapping model. You can show again your presentation about.
Yes. Okay. The flood mapping, this is used initially. We have tried with HMS. I would say it is very user friendly, and it's working with students. It's really very good start. So once we tried with HMS also consider urbanization, but people wanted to see the urban drainage influence, what happened if there is a rainwater harvesting implemented. So then my research team has moved to SWIM model, and SWIM model which is freely available. At the same time, SWIM model work, we also incorporated to some findings using PC Swim. And PC Swim have more features, but the issue is from university people, they can ask for the academic license. And the PC Swim, they are very generous. They give it for 1 year uh, license for
License.
free. Yes. But for swim model, you don't need any license. So you can, if you wanted to start with a swim model, that will be like free of cost, and you can have all the LID, low impact development option there. So for a particular area, you can select all the low impact development or LID. Like if you want to make it a green roof uh, options and wanted to see how much reduction is there, that can be done. Similarly, if you want if some places having bioretention soil, that can be also incorporated in swim model.
What about the resolution, the data for input the PC apa? SVMM, PC SVMM.
PC swim have the same, but the options are like more wide. Some of the places, but now most of my students, they don't wanted to go for PC swim. They just wanted to work with the swim model because this is freely available and accessible as well, and their customer service is also very good.
Okay, thank you. Because difficult to mapping for large using hydrodynamic modeling in my
Yeah, I understand. Modeling and mapping is difficult, but rather difficult is validation. When from our case, we have some places don't there is no gas, so we need to work like parallelly. One group has started collecting data over there, and the next group is working on the model. So primary data is required for this purpose. For the validation for a short time, at least we need to get data from the field measurement.
maybe using ground checking for the validation.
Yes. Otherwise, it is very difficult to convince reviewers.
Thank you. Monggo Bu Retno, saya kembalikan. Thank you, Aisyah.
Okay.
Thank you. There is okay, another question. Please.
I think I would like to ask question to Prof. Aisyah. I apologize first if it's already been discussed before. I have a question. Can the formula be applied in other countries that have different topography and climate, like Indonesia or any other country?
Thank you very much. That's why I am interested to give this seminar, and I just wanted to make like comparison. So any I can share. It's already on my website. There are different works for only drinking purpose. There is a work stormwater management. There is a work for groundwater recharge. There is a work for both groundwater recharge and stormwater management. So any of the work can be repeat for Indonesia, and then we can compare. We can compare the findings. The topography before starting a work like international comparison, we will find like similar interest. Like it can be coastal side. Okay, let's make a comparison between two coastal area. It can be compared for the hilly area. We have hilly parts, and the place I am living, it's nearby. It's a hilly area. We can compare.
Thank you very much for the answer, Prof. Isa.
Thank you.
Okay. There is another question that come to my side on the chat, the private chat. Um, uh, in
Okay.
your slides,
Okay. Yeah, I cannot see. It's from. It's just only yours chat box.
okay, okay. Yeah, yeah. Only my
Please, yes,
just
please read it
related
out.
to my chat. So the question is about the figure that you show about the potential rainwater harvesting roof, which has the level of good, moderate, and poor. So, what
Okay.
is the parameter, or how we can select that which one is good or best or moderate? And
Okay. That's really a good question. Who asked this one? Any faculty member or a student? This is really
yeah,
good question. Okay. Whenever we make this research work, today my presentation was has two part. One is the general talks from my book, and then some of the findings from my research work. So this place, we wanted to make it at least understandable for the uh, owners or the community, which is highly potential. So in that case, we just used AHP method. AHP stands for Analytical Hierarchy Process Method. So over there, we have a few criteria. Initially, we started with four criteria only. The roof area, one of them. Then, as it is the urban area, we don't move for land use, land cover. We just pointed out the roof area. Then the drainage area, then the drainage density, then runoff. We pointed out runoff, and also the slope. These four criteria we have applied, and then we take the uh, options, and we discussed with experts which criteria influences more than the others. So based on these four criteria, we have divided the whole area as three categories. This is the most potential rainwater harvesting area. We call it index, high potential index, high, moderate, and low. This is the way we have calculated, uh, and there is not much change in this is there is not much change in roof material, like the concreting roof. We have the same runoff coefficient consideration, not different than others. And we have just two modes. One is concreting roof. Another one is corrugated iron roof. But whenever for the city area, we pointed out the rooftop, which having concreting area, those are considered for this index calculation. But we also left some provision for the area which has open land. But rooftop rainwater harvesting belongs to only for the roofs. Very good question. I should have mentioned during my presentation how this come. But thank you. I will share this paper if you are interested to work on it.
Yes, yes, sure. Thank you very much for the answer, Prof. Aisa. Um, Okay, I think we come to the end of our session today. So, once again, we would like to thank Prof. Isaac for coming and also the explanation, a very clear and a very inspiring presentation today. We hope that later we can uh, also join for the research or academic lecture. Uh, okay, then I will give back the session to Master of Ceremony. Thank you, Prof. Isa, and all the participants.
Well, ladies and gentlemen, that concludes our guest lecture today. We would like to, Ladies and gentlemen, that concludes our guest lecture today. We would like to express our deepest gratitude to Prof. Aisa Akhtar, MPhD, for the insightful presentation, to Bu Rotma Utami for guiding the discussion, and to all the participants for your attention and participation. Before officially closing our event, we would like to ask all the participants and invitees in the Zoom meeting to turn on their cameras. We would like to do screen capture for the documentation. Um, Please, everyone, to turn on their camera. Like to count to three. 1, 2, and 3. So thank you. We hope today's session has been meaningful and inspiring. Thank you for joining us. Wassalamualaikum warahmatullahi wabarakatuh. Good morning and see you at our next event.
Allah Hafiz and goodbye, everybody. Thank you.
Thank you, Aisa. Thank you.
Recording stopped.